Hi guys. Okay, in the previous two videos, we covered some conversions, and I showed you how to convert from any base whatsoever, and we did hexadecimal and binary. How to convert into decimal, and then in the second video, I showed you how to take a decimal number and convert it into some other base. So you should be quite clued up on how to do those now. If you're not, then you can pop back and just look at those two videos again. They are very easy. So the last piece of the puzzle I'm going to show you now is how to convert between hexadecimal and binary, and from binary to hexadecimal. So we will tackle, first of all, hexadecimal to binary. So what you want to do is make yourself a chart like this, okay? Until you get used to this, and you will soon get used to sort of what the binary number is of each of the hex numbers, okay? But until you get used to that, just make yourself a chart that looks like this. And you can see down here we've got the 16 hexadecimal digits from 0 up until F. Okay, remember with hexadecimal, we've got these extra 6 here. There's A, B, C, D, E, and F, which is 10, 11, 12, 13, 14, and 15. Okay, so we've got those extras in there. And then what we've done is we've taken each one of these hex numbers, each one of these hexadecimal numbers, and we have written on this side its binary equivalent in 4 bits. So we have taken 4 bits and we've written the binary equivalent of each one of these hex numbers. Now, this is the clue about how we are going to do these conversions. We are going to use this fact, the fact that we can take each hex number and write it as 4 binary digits, okay? Or we can take 4 binary digits, a group of 4 binary digits, and write that as a hex number. Okay, so we are using the fact that 2 times 2 times 2 times 2, that's 2 to the power 4, is 16. Okay, so that is, we are going to use that fact to do our conversions. Okay, so get yourself a chart like this, and we're ready to go. So I'm just going to pick a random number. Let's say a random hexadecimal number. Let's say 193. Okay, 193, it's a hexadecimal number, so we need to have a little 16 at the base here just to tell you it's a hexadecimal number. Okay, that there's not part of the number, it's just telling you that this is not 193. Okay, 193 would be decimal. This is 193 hexadecimal. So what I'm going to do is I'm going to take each one of the digits. Okay, so each one of these hexadecimal digits, and I'm just going to write it as its binary equivalent. So 3 is 0, 0, 1, 1. You can just look that up in the table and you'll see that. Okay, we know that when it comes to binary numbers, this is the 1s column, that's the 2, that's the 4, that's the 8 column. So I've got 1, 2 plus 1, 1. Okay, so I know that that is 3. Now I'm going to take the 9 and I'm going to write this here, as its 4-digit binary number. Okay, so that is 1, 0, 0, 1. Okay, so 1, 0, 0, 1, that is 9. Okay, once again, we know that that's the 1 column, the 2 column, the 4 column, and the 8 column when we're looking at binary. So I've got 1, 8 and 1, 1 gives me 9. So that is 9. Now I come to the 1. Okay, so the 1 is 0, 0, 0, 1. So there's my answer. 193 hexadecimal is this in binary. Obviously, we can leave those 3 zeros out. Okay, so any leading zeros, we can just chop them off, because they don't actually add anything to the number at all. So 193 hexadecimal is 1100100011 binary. Okay, and because it's binary, we should put a little 2 at the bottom, a subscript 2. Okay, so that is 193. Right, I'll do another example for you. So let's just delete that. Okay, so let's say this time around, I'm going to pick, let's say, F A C E. Okay, face. Okay, that's a valid hexadecimal number. We're using only hexadecimal digits here. We know that we've got A, B, C, D, E, and F that we can use. So that is a valid number in hexadecimal. So let's convert that to binary. So we know that we know that A is 10. Okay, so if we go back to here, we go back to our chart, we can see that E is 1110. Okay, so it's 3 1s and a 0. So let's go and write that. 1110. Okay, C, I know is a 12. So I've got 8 and 4 is 12 and 0 and 0. If I go and look up what C is on my chart, I can see it's 1100. Okay, let's have a look at the A. We know that A is 10. So I've got 1010. So if I look on my chart, I will see that A is 1010. And lastly, we're going to do the F. We're going to break that into four digits. And that is 1111. So there's my answer. Okay, FACE hexadecimal is 1111, 1010, 1100, 1110 in binary. Okay, so very easy. You can see how we did that. Okay, let's have a look at the other side of the equation. Let's say we are now going to convert a binary and we want to make it into hexadecimal. So let's pick a number. Okay, so I'm going to pick here 1 0 0 1 1 1 0 0 1 1. Okay, so we've got that number. There's a binary number. Okay, so first thing you want to do when you do this conversion is you want to split, okay, you want to split your number up starting from the right, okay, they call this the least significant digit. So starting from the right hand side, we want to split our number up into groups of 4. Okay, so I've got 4 digits there, I've got 4 digits there, and over here you can see I've only got 2 digits. So what I can do is I can just add some more zeros over there. Okay, we know that if you've got the number 7, then if I put 2 zeros in front of it, then 007 is the same as 7. Okay, it doesn't matter. If you put zeros in front of a number, it doesn't matter. It doesn't add anything to the number at all. Okay, so I've put some digits on the end of it there just to make up the group of 4. Okay, so I look at this here now and I say, well, what is that in hex? Well, I know it is 3. Okay, so I looked up in my table and I could see that 0011 is 3. Now I look up in my table and I see, what is that? Well, I know that 0111 is a 7. And if I look in my table for 0010, I see that is a 2. So I'll put a little 16 there. Okay, there's a little 2 there. So that number there in binary is that number in hexadecimal. So let me do one more for you. Okay, so let's try another one. Let's try this. 1, 1, 1, 1, 1, 0, 0, 1, 1, 1, 0. So let's say we've got that number. Okay, so I showed you before what you've got to do. Step number 1 is starting from the right, we break it up into groups of 4. So there's a group of 4, there's a group of 4, and I can see that I need let me just go get that to be a black. You can see I've got to add a 0 there to give me that last group of 4. Right, so if I look at this here, I've got just this group here. I can go and look it up in my table, and I can see that that is 8, 12, that is 14. Okay, so I know that 14 is going to be 10, 11, 12, 13, 14 is an E. Okay, so 1110 is an E. 1110 is an E. 1100 is going to be a C. I just looked that up in my table. Okay, that's 8 and 4 is 12, and C is 12. Okay, and 0111 is 7. So that number there, that big long binary number, is 7CE as a hexadecimal number. So that's it. Okay, all you're going to do is you break it up into groups of 4 starting from the right, and you just write each group of 4 as a single hexadecimal digit.